Alright, so this is the video for Chapter 2, Section 4, Part 1, or Part A, I think our note says. So in this section, we're going to talk about how to write equations of quadratic functions, given a few points on the graph. Okay, so let's look at this first one here. A lot of this is just kind of review. But it tells us this is a quadratic function. So remember, quadratic functions is ax squared plus bx plus c, or in this case it's a t squared plus bt plus c. You'll see t used a lot when you're talking about time. So of course down here along the x-axis we're talking about years. So that's probably why the author used a t rather than an x. Alright, so we're approximating yearly profits for a company. Okay, so it says, is the value of A positive, negative, or zero given this graph? Okay, well you should know by now that if A is positive, it goes like this. If A is negative, it goes down like this. So we can't see this turn a lot, but we can kind of, it's a very wide graph, but we can definitely see that it is pointing upward, which would make A a positive number. Okay, and once again, that's just because it's pointing up. It says the company made the same profits for the year 2004 and in 2012. Estimate the year in which the company made the least profit. All right, well, we don't know if 2004 is here or whatever. So let's just pretend, I don't know, let's pretend that 2004 is here. Okay, so this is 2004. And then in the same, in 2012, they made the same profit. So let's say this is 2012. Now, I'm remembering that the qualities of a quadratic function is that it's symmetric. That means the minimum, or the vertex, minimum vertex, whichever, would have to be halfway between these 2 points. Okay, so remember to find the halfway distance, we would just take the average of the two. Okay, and that would be what, 2008? Okay, so in the year 2008, they made the least amount of profit. Okay, now on Part C it says, assume the model is still valid today. Are the yearly profits currently increasing, decreasing, or constant? Well, guys, this is a quadratic function, and while it's super wide, it's just going to continue, assuming this model stays true. Now, will this model stay true forever? Probably not. But assuming it stays true for how many ever years, and it's still true for today, our profits would definitely be increasing. Once again, because we've already hit our minimum. Okay, we only increase after that. All right, so let's now look at example 1. We're actually going to learn something new. We're going to learn how to write the equation of this quadratic function given the vertex and another point on the graph. And it doesn't matter what that point on the graph is. In this case, it's the y-intercept, but it does not have to be the y-intercept. It would work the same for any other point on the graph. Okay, so this is the graph of the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled. We want to write an equation of the parabola in vertex form. All right, well, we are given the vertex, so that means we should write this quadratic, or we should start writing it in vertex form. Okay, so remember, vertex form is y equals sum a, and then it's x minus the x value of the vertex, and then it's plus 35. Okay, so this is just vertex form. This is a review from, I believe, section 2. So you should be able to get to this point without having to think a whole lot. All right, now we have to find what A is. Okay, so I've already used this vertex. We want to use another point on the graph. So now I'm going to use the point 0, 15. Okay, And notice that this would be a solution to this problem because it lies on the line. So I'm just going to plug 15 in for y because that is my y value, and 0 in for x because that is my x value. Okay, so when I do that, I get 15 equals a 0 minus 50. Guys, I forgot a square here. My bad. Squared plus 35. Alright, so if I go a step further, 15 equals negative 50 squared is negative 50 times negative 50, which is positive 2,500. Okay, now it's just simple algebra. So negative 20 equals 2,500a. And guys, a lot of times, not always, but a lot of times these a's are going to be super tiny. Okay, so this one's going to be pretty small. So negative 20 over 2,500 simplifies to negative 1 over 125. Now, if you do not know how to simplify this using your calculator, let me know in class and I can help you out. Show you how to do that pretty easily. So negative 1 over 25 equals a. Okay, well now we've done the hard part. Now we just have to put it back together. We have to substitute a in for here. So the entire function is f of x equals negative 1 over 125 x minus 50 squared plus 35. That is my final function. Okay, so if I go down to part B, it says the performer lands 90 feet from the cannon. Okay, so 90 feet out is right here. What is the height of the net? How high are we when our x value is 90? So I would just plug 90 in for x. (90 minus 50 squared). Okay, and when you plug that into your calculator, you get roughly 22.2 feet. And that's your final answer. All right, so I want you guys to pause this, look at the example 1 that we just did, and try to work this one out on your own. So go ahead and pause this, try to work this one out on your own. If you get stuck, go back to see what we did in example 1. All right, so this is what you should have got.